Scatter plots help us see the relationship between two variables. In this lesson, we'll learn how to describe trends in data and how to sketch a line of best fit. We can sketch a line of best fit that more or less goes through the middle of the data to show the overall trend in the data. Technology can make these lines more precise, but for now, we can just estimate them ourselves. This line of best fit slopes up and to the right. This one has two linear trends, one that slopes up from left to right and one that slopes down from left to right. So there's not one line that fits it well. So in this case, there is no line of best fit. We can also see multiple linear patterns in this scatter plot, but there's also a single line of best fit that fits the overall pattern pretty well. One interesting thing about this line of best fit is that it is pretty much horizontal. This graph displays the relationship between the age of drivers and the number of accidents they have. Age is on the x-axis, and the number of accidents per 100 drivers is on the y-axis. Also, notice that this study only looks at relatively young drivers. For this scatter plot, let's describe the overall direction of the relationship between driver age and accidents. Notice that as we go from left to right in this scatter plot, the age is increasing, but the number of accidents is decreasing. So older drivers tended to have fewer accidents. Or in other words, as age increases, notice I'm going left to right, as age increases, accidents decrease. So as age is going in one direction, the accidents are going in a different direction. When describing associations we see in scatter plots, it is important to use context and not just say it goes down. So in this example, notice that we started with the x-axis variable in our description and described what happened to the y-axis variable as we moved left to right. This graph shows the relationship between test grades and shoe size. Each dot represents one student's shoe size and their score on the test. So this student here has a shoe size of 10.5 and got a 60 on the test. This scatter plot does not show a pattern, so we cannot describe a directional association between the variables. We should just say there is no clear relationship between shoe size and test score. This scatter plot shows the relationship between average heart rate in beats per minute of several mammal species and their life expectancy in years. Each dot represents the heart rate and life expectancy of one species. For instance, this dot might represent mice who on average have a heart rate of 600 beats per minute and life expectancies a little less than or a little under 5 years. Even though the relationship between heart rate and life expectancy is not linear, we can still say that species with higher heart rates tended to have lower life expectancies. So once again here, as heart rate increases, the life expectancy is decreasing. This scatter plot shows data collected at a test track regarding the fuel consumption of a car at different speeds. For instance, this dot shows that when the car was driving 120 kilometers per hour, it used almost 10 liters of fuel. Right away, we notice that there are two patterns. As speed increases while driving at slower speeds, the amount of fuel used tended to go down. So going from left to right at these slower speeds, the amount of fuel used is going down. But when speed increases at faster speeds, the amount of fuel used tended to go up. In other words, when driving slowly, speeding up helped the car use less fuel, but when driving fast, speeding up used up more fuel. So we cannot make one grand statement about the association between speed and fuel consumption because it depends. One thing we could say, though, is that the amount of fuel used was lowest at speeds around 60 kilometers per hour. I hope these examples about using lines of best fit on scatter plots have been helpful. This is Mr. Ela, signing off.